Hello grade 8s, and welcome to lesson 3.4 on using the Pythagorean relationship. So we already know that the Pythagorean relationship is this a squared plus b squared equals c squared equation, which represents the relationship between the side lengths in a right triangle, where A and B are the legs of the triangle and C is the hypotenuse. So when we're talking about using the Pythagorean relationship, we're talking about applying that equation to solving a right triangle in some kind of situation. So for instance, in example 1, where it asks us to find the lengths of the missing sides and round your answer to one decimal place if necessary, what we're going to do is we are going to be using a squared plus b squared equals c squared in each case. And in this case, we know that 3 could be either a or b, and it doesn't matter if you reverse these, as long as you make c the hypotenuse. And we know that c is the hypotenuse because it's the one that's diagonally across from the right angle. And so C is our missing side that we're going to find its length. And now we can plug in numbers. So since we know that A is 3, we can substitute that in here. And we know that B is 4, so we can substitute that in here. So let's do that. We're going to replace the A with the 3, and we're going to square it. We're going to replace the B with a 4, and we're going to square it. And that will be equal to C squared. So 3 squared means 3 times 3, which is 9. 4 squared is 4 times 4, which means it's 16. And when I add those two together, I get 25, and that is equal to C squared. So when I'm thinking of a number that squared gives me 25, I'm thinking that's 5. The way that you can get that answer in each case is to take the square root. So taking the square root of 25 gives me 5 centimeters, and that is my final answer for the length of the missing side. Let's do that again for example B. This time we have some different side lengths. So first of all, let me write down the Pythagorean relationship. It's a squared plus b squared equals c squared. And again, it's important to notice where a, b, and c are. This 5 meters could either be a or b, and it doesn't matter if I switch them. Because it's a leg, that's a. I'm going to call my missing side length b. And finally, C is the 13, and I know that it's C. I know it's the hypotenuse because it's the one that's across from the 90-degree angle. I can also tell pretty easily it is the longest side in this triangle. Now I'm going to do substitutions, so I'm going to replace A with 5. I'm going to replace, well, I can't put anything in here for B. B is the unknown. So instead, I'm going to replace C with 13. Okay, so let's do that. Replace A with 5, and I'll be squaring that. B is the unknown side length. I'm going to be looking to find that out. And C is 13, so I'll be squaring that. So 5 squared means 5 times 5, that's 25. B squared, this is still unknown. C squared is 13 squared. 13 times 13 is 169. And now we're looking to find out what B is. We know that if we square it and then we add 25, it'll give us 169. So what I'm going to do to get B squared is I'm going to do 169 minus 25 first to find out what B squared would be on its own. So B squared is 144. And so therefore, if I'm looking for a number that when I square it, I get 144, that number is going to be the square root of 144. And that's equal to 12. And this is 12 meters in this case. That is the missing side length. So those are the first two examples. We're going to take a look at one more here in example 1. And this is one that you have to be very careful of because often people get A and C confused. They look at the fact that there are two side lengths given and they're 3 and 4. The third side length is 5 centimeters, and so this is a very common triangle that's used. It's a Pythagorean triple. We call it a 3, 4, 5 triangle. So often when students see the 3 and the 4, they assume, oh, automatically this is 5. Well, if you think about it, first of all, and I didn't label where the right angle is, but you know that this is the right angle. So if that's the right angle, and this is the hypotenuse, which is the longest side, so I'm going to label that as C. If I put 5 meters here, then automatically you should be looking at that and saying, whoops, now the longest side is not the hypotenuse. Well, that's impossible. So I'm just going to erase this and see what we really should get for this side length, this missing side length. So let's suppose that I say this is B and I call this A. It doesn't matter whether I call the missing side length A or B. It has to be one of the two because it is a leg of the triangle. As long as C is the hypotenuse, that's the 4 meters. Okay, so again what I'm going to do is I'm going to write down that Pythagorean relationship, which is a squared plus b squared equals c squared, and I'm going to replace b right here with 3. I'm going to replace c right here with 4. And so when I do that, this is what the equation will look like. In place of b, I put 3. In place of c, I put 4. And so 3 squared is equal to 9. 4 squared is equal to 16. And now, when I square a, that gives me a squared. I'm going to add 9 to get 16. So to get a squared by itself, I have to do 16 minus 9. And so a squared is 7, which means that a is the square root of 7. Now, I know that 2 squared is 4 and 3 squared is 9, so the square root of 7 should be somewhere between 2 and 3. Now, I can guess maybe 2.7, but to get the answer for sure, and we are going to be rounding to 1 decimal place because that's what was specified here, round to 1 decimal place. I'm going to need to do this on my calculator. So I'm just going to bring up my calculator. And here we go. The square root of 7 is equal to approximately 2.6. Now that is close to what I expected because I had thought about that prior to calculating. I'd done a little estimation in my head, and now I know that the answer is reasonable. Okay, if my calculator gave me some other answer, like 26 or I don't know, something like that, and then I'd say, oh, wait a minute, I have to recheck my math. Okay, so that's that. Now let's take a look at how we can apply the Pythagorean relationship in a word problem. I'm just going to put the calculator away, and let's take a look. It says a rectangular field is 12 meters wide and 16 meters long. How far across is it across the diagonal? So it would be a good idea for me to draw a diagram of this. So here we go. So it says that it is 12 meters wide and it is 16 meters long, and of course it is rectangular, so this is a right angle. And going across the diagonal means we're going from this corner to the opposite corner. That's diagonal. And so if we want to know how long that is, then really we are finding C, the hypotenuse, in a right triangle, because look, this is across from the right angle, and so I can call this A or B because it's a leg. Again, this B or A. because it's a leg, and c is the hypotenuse. So let's write down the Pythagorean relationship. It is a squared plus b squared equals c squared, and I'm going to be replacing a with 16. I'll be replacing b with 12, and let's see how that turns out. So it's 16 squared plus 12 squared is equal to c squared. 16 squared is 256. 12 squared is 144. And so this gives me 256 plus 144 is equal to 400. And that's c squared. So to get c, I'm going to take the square root of 400, which is equal to 20 meters. And that is the distance across the diagonal. So that's the end of the lesson. Here's the assignment for both the regular and honors class, and thank you for watching this video.